Okay, we look at the modulus, which is the strength. Metal and polymer, yield strength. Ceramic and glasses, elastomer tensile tear strength. Composite tensile failure. So this one show the design guideline, and this one is the buckling before the yield. See that the properties of the polymer is lies in here, right? In the range of 10 to 100 strength, okay, 100 MPa. And the good one is the metal, of course, in terms of the strength. Okay, in terms of the specific strength, polymer lies here, and okay, you can see that this is the loss coefficient modulus, right? Potential benefits of the plastic over the metal. Okay, plastic of course, it is more cheap, and we can inject complicated parts. Okay, plastic also don't need to be painted. Okay, it has a better corrosion resistance compared to metal, easily made, domestically pleasant, and the last one, it is lighter. Right. This table shows the comparison of the relative properties of amorphous and crystalline thermoplastic. Okay, for amorphous thermoplastic, you can see that the tensile strength, the tensile modulus, ductile toughness, and water resistance shrinkage is lower compared to the crystalline. Okay, so for amorphous, the isotropy is the isotropic, and for crystalline, it is the anisotropic. Okay, the opacity for amorphous, it is transparent, while for the crystalline, it is opaque. Okay, we look at the material type, which are amorphous. For example, we have PVC, GPPS, PC, PMMA, ABS, and so on. And for semi-crystalline, for example, PE, HDPE, PP, PET, POM, PTFE. Okay, this depends on the application that you want to make. Okay, depend on the application. So the choice of the material is very crucial. All right, we look at the study case. For example, a chair. How we want to choose the material for a chair. So in this case, example, we use the material which is polypropylene. Okay, why? Because PP is a thermoplastic, and therefore it is very suitable for injection molding. Besides, it is stiff but will flex slightly to prevent fracture under shock load. For example, when someone sits on it or leans back. Okay, PP also available in a wide range of colors and which is pigments, and it does not require any finishing or future maintenance. And it is weather resistant, but the color and the surface tend to degrade over time if it's left outside. Okay, now back to the material properties data obtained from suppliers or the manufacturers. Okay, so this slide is about the material properties data that we obtain from the vendor. Okay, so first thing, it is about the principal use of the manufacturer data is to provide a short list of the material to be drawn up for further investigation before final selection. So all the data from the material department, from the suppliers, is very crucial for you. Okay, because the data is needed for you to make the comparison. If the data containing the testing that have been done by that material, so we need to compare the data with our own data that we're going to do the next step, right? Despite the limitation, so they do enable unsuitable material to be rejected with reasonable degree of reliability. So if the place that you work they did the test, same test with the company or the material supplied. For example, if you do the strength test of the material and the result is slightly different with the test conducted by the suppliers, so you have the proof to reject the material with reasonable degree of reliability. Okay. The second one, the standard tests are designed to give representative and reproducible data in the short time using fairly simple equipment, right? There may be variation in the standard methods. For example, method for determining the softening point by HDT using load of 1.81 MPa and 0.45 MPa, which lead to different value for a given property. So there may be different standard tests available to assess a particular properties, such as a Sharpie and ISO impact test, which lead to quite different value. So the standard tests, they will design the standard tests on the material properties too, because we want to produce the data which is simple, okay, fairly simple equipment. So these values are typical rather than a specific grade of polymer. So only rarely is the information given as modified grade. For example, glass fill, mineral fill, and etc. So material properties data obtained from suppliers also give the properties of the product made from the material will depend upon the manufacturing method of the materials by the manufacturers. And um, the last one is the plastic material or viscoelastic to a greater or lesser extent and therefore creep under load at room temperature, a phenomena which increase as the temperature is raised. And if the product is to be used under conditions of stress, especially if the product lifetime is expected to be a long one. So hence, the stress relaxation property should be considered. So only rarely are these properties covered by manufacturer's data, and even then, the work may have to be done before an appropriate material can be selected. So therefore, obtaining a short list, the designer will make the final selection based upon the factors such as availability of materials, the economic, and manufacturing process. Okay. This is types of the typical mechanical properties of xenoid range properties. Okay, this one is the material properties obtained from supplier. Okay, the material name is xenoid, and it include the tensile modulus, tensile stress, the impact, the thermal. Okay, according to the method here, it gives the standard method run for each test, and several xenoresin have a fillers for unfill, MF, HMD grade, IQ, HMD, and so on. Right? Okay, thank you. That's all for the material selection.